Language is central to our society and culture, and it's something we use almost every minute of our lives. There are thousands of diverse languages, and they can be used to connect people around the world. So how do we develop speech, and why is our communication distinct from other animals? Traditional linguists like B.F. Skinner believe that behavior, such as speech and thought, were learned from interactions between organisms and their environment. Noam Chomsky is considered to be the father of this branch of biolinguistics because he rejected this belief and proposed that humans are born with innate language ability that is genetically inherited due to Darwin's theory of evolution, his observations of childhood language acquisition, and his theory of universal grammar, which proposed that if human beings are brought up under normal conditions, then they will always develop language with certain properties because there is an innate, genetically determined language faculty that knows these rules, making it easier and faster for children to learn to speak it. If we consider Chomsky's biolinguistic theory, then we must look into our evolutionary past to reveal the origin of human language by observing the speech patterns of primates. Most notably, gibbons show evidence of grammar in their construction of complex songs from syllables called song elements, so that the way the song elements are strung together gives songs their meaning. This bears similarity to human grammar, but is still far from the complexity of human language, which could show how speech first arose in humans. So why is human speech so much more complex than our primate relatives? One explanation comes from the way our tongues are positioned over the oral cavity and the pharynx, forming the supralaryngeal vocal tract and giving us the ability to produce a wider range of speech sounds than human infants and other mammals whose tongues rest almost exclusively in their mouths and form a sealed airway with the larynx. Another reason may lie in the crucial FOXP2 gene, which encodes for the FOXP2 protein, a transcription factor that regulates gene expression in the brain. This gene was discovered by the study of the KE family, who exhibited a severe language disorder that was found to be caused by mutations in the FOXP2 gene, leading to the theory that the gene plays a large role in speech and language development. While many other species have the FOXP2 gene, Homo sapiens, Neanderthals, and Denisovans share a special mutation of the gene and have more complex language circuits for processing speech, which give humans a greater ability to produce unique, complex combination of syllables and words. In 1971, Philip Lieberman and Edmund Craylen conducted a study using a computer model of a Neanderthal vocal tract and archaeological evidence to conclude that Neanderthals had speech and language capabilities, placing the origin of human language up to 300,000 years ago. In conclusion, we still have very limited evidence to explain the development of speech, but many linguists stand by Chomsky's theory of innate language ability and continue to base their research on Darwin's theory of evolution, giving us a greater understanding of the origin of language.